First, we simply plug in x equals infinity to get this x infinity times sine 5 over infinity. 5 over very big, that means very small, 0. Okay, fixed number divided by infinity is 0, and sine 0 is 0. So infinity times 0. Okay, do not conclude 0 times infinity is 0. 0 times a finite number is 0, but this is an indeterminate form. And to evaluate this limit, we want to write this in a fraction, so that we might get like 0 over 0 or infinity over infinity, in which in this case we can use L'Hopital's rule. But we have a product, so we want to write as a fraction. As in previous question, when we have a times b, we have two options to change this into fraction. We can keep b on the top and this a 1 over a on the bottom, just the reciprocal of a. When if you change this division into multiplication, you get back to a times b. Or you can change a times b, keep a on the top, 1 over b on the bottom, same thing. So let's try to make this as a fraction. Okay, why we are making a fraction? We hope we would have like 0 over 0 or infinity over infinity. Then to evaluate this limit, we can use L'Hopital's rule. Let's move x. Okay, moving sine 5 over x, this is more complicated. So sine 5 over x on the top over this x on the bottom as a reciprocal, 1 over x. Okay, now let's plug in x equals infinity and see what we're gonna get. Sine 5 over very big infinity, 5 over infinity. Okay, that's 0, and sine 0 is 0 on the top, and 1 over infinity, 1 over very big, very small, 0. So we get 0 over 0, which is an indeterminate form, but this is kind of nice. This is nicer than the previous one, because now to evaluate this limit, we can use L'Hopital's rule. Okay, now using L'Hopital's rule, this limit is equal to the following limit, where we find the derivative of top on the top and derivative of bottom on the bottom. Okay, so let's find the derivative of top. That's kind of not easy. So sine 5 over x, let's do it over here. It's like sine of some function inside, let's say u, outer function, inner function, and the derivative of sine of inner function is derivative of outer function. Derivative of sine is cosine at inner function times, from chain rule, derivative of inner function. Okay, so in this case, derivative of sine 5 over x is cosine 5 over x times derivative of 5 over x. So I'm going to write derivative of 5 over x, and I'm going to differentiate in the next step. Okay, on the bottom, a derivative of 1 over x. I want to just keep 1 over x, derivative of 1 over x. Okay, and we know derivative of 5 over x, we can pull 5 constant outside, and we will have 1 over x, 1 over x. Okay, and we know the derivative of 1 over x, and derivative, we found that in previous, this is number 10, number 9. Derivative of 1 over x is, it's like 1 over x is same as x raised to negative 1 xn, so n x n minus 1, so negative 1 x negative 2, so negative 1 over x squared. By the way, derivative of 1 over x is negative 1 over x squared, but we don't have to find the derivative. Why? When we take 5 outside, we're gonna have 1 over x derivative of 1 over x, and same thing on the bottom, derivative of 1 over x. Okay, whatever that value is, they simply cancel. So if you like, you can find the derivative of 5 over x, which is 5 outside, and derivative of 1 over x is negative 1 over x squared, and here same thing, negative 1 over x squared, and you cancel negative 1 over x squared to negative 1 over x squared. But I would not even find the derivative. I would rewrite in this way, pull 5 outside, and we can pull all the way to front, 5 and cosine 5 over x. So what I did here, I cancel these two and just survive 5. 5 outside, 1 over x, derivative of 1 over x and derivative of 1 over x I cancel. So that 5 I'm pulling all the way to the front. Now let's plug in x equals infinity to see what we're gonna get. So this is 5 times cosine 5 over infinity. 5 over very big, that's very small, so 0. Cosine 0, and cosine 0 is 1. So 5 times 1 is 5. Okay, so see, 0 times infinity, that's not 0. Now we found 5. But in the previous question, number 9, 0 times infinity, that was 0. In fact, changing this number 5, like 1, 2, 3, 4, any number, we get that number as an answer.